Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today we will continue with the problems on fluid mechanics, problems on with the students recommendation. This question has been recommended by Amit through WhatsApp. Okay, so you can contact me through WhatsApp also. Okay, XEB 2015 question 19. Let us see this problem. The problem goes like this. Consider the following figures shown below. The objects marked as A1, A2, B1, B2 and C1, C2 and the flow directions over these objects are shown by the respective arrow placed to the left of the object. Free stream velocities are the same for all the cases. Amongst these objects A1, A2, B1 and C1 have smooth surfaces. That means A1, A2, B1, C1 have smooth surfaces, while B2 and C2 have rough surfaces. Reynolds number is such that the flow over the rough surfaces become turbulent and flow over a smooth surface can be considered as laminar. All the airfoils can be considered as a thin slender airfoil. Among the statements 1 to 6 made about drag of these objects, which is or are correct? Now if you see here, the questions are like this. Drag of object A1 is less than that of A2, or drag of object A1 and A2 are same. So let us see 1 and 2. What is the answer for these two? Which is correct among 1 and 2? Let us see. Let us see what is the reason for drag which is there. What are the types of drag? The major types of drag is form drag or pressure drag, or friction or viscous drag. Now let us see what causes these things. When you consider form or pressure drag, it is because there is difference in pressure between the downstream and upstream of the object. For example, this is a rectangular object. Now here when the flow is there, the pressure will be high here and pressure will be low here. Because of this, there is a drag which is experienced. So this is called pressure drag. What is meant by friction drag? Friction drag is there is a formation of boundary layer over the surface. And this boundary layer formation induces a stress at the boundary. For example, tau W, that is you say the shear stress. Okay, shear stress tau W is given by mu into du by dy at y is equal to 0, and this causes the friction. Okay, so that is called the friction drag. This is the friction drag and this is the pressure drag. Now when there is a laminar flow, okay, what is happening, because laminar or turbulent, whatever be the case, now if I have the flow which is coming like this, now there is a formation of boundary layer over an object. Okay, now when it is going from here till here, this point, there is favorable pressure gradient. That means as we go from here to here, the pressure reduces. So since pressure reduces, there is a favorable pressure gradient and flow can happen. But on the other side, there is unfavorable pressure gradient, because of which the boundary layer can separate and this shear layer which is there, which is inside this, can separate. And this separation points, okay, this separation points here, okay, till here, this is called the shear layer, and this may interact and form vortices. That's a different point. Now because of this, there is a wake region here. This is called the wake region. Now larger the area of the wake, higher the pressure drag. Okay, larger the area of the wake, higher the pressure drag. So now what is happening in the first case, if we see the wake which is the separation over here, this doesn't allow sudden increase of pressure. Okay, it offers a gradual increase of pressure. When it is a gradual increase of pressure, the separation is delayed. So there might be a separation somewhere here and the area of the wake is reduced considerably. Whereas in the second case, A2 case, this is okay, there is a favorable pressure gradient, but over here what is happening, the separation happens earlier than this. So the wake area is high. Because the wake area is large, what is happening? The drag in A2 is greater than that of A1, or A1 is lesser than that of A2. So 1 is right. Now let us see the third and the fourth one. Okay. Now if you see the third and the fourth, now here drag on the object B1 is more than that of B2 and B2 is greater than B1. We are comparing both of them. Let us see what happens. Now generally when the flow becomes turbulent, okay, the boundary layer separation is delayed. What is the reason for that? This has to be understood like climbing a what you say, or we can say, yeah, a car climbing, or a wheel, for example, or a roller, okay, climbing a steep hill. Okay, now you have to push this roller with a velocity. Because of this velocity, it will go up the hill. Okay, here there is an unfavorable gradient. Okay, the gradient is unfavorable here. It is not, if the gradient was like this, then it would easily go down. But if the gradient was the other way around, it is not favorable. Same thing happens between this point and this point, unfavorable. Okay, from here to here, it is similar to this point. Okay, or we can also say like this. 1 second, students. So we can put it like this. Okay, this is the way, and there is a roller here, and which is rolling over this. Okay, till here it is favorable, and till when it goes here it is unfavorable. Okay, so now if the velocity here was higher, then this would move to a larger distance. Okay, so it would move to a larger distance. Similar thing happens when it is a turbulent flow. Turbulent flow has higher energy. Because it has higher energy, it can pull on with unfavorable pressure gradient. That is why if this is laminar wake, in the turbulent wake, what is happening? The separation, the boundary layer separation is delayed. The boundary layer separation is delayed in the case of turbulent flow. Now it is said that B2 is a rough surface and the flow becomes turbulent. So because it is a rough surface, and it becomes turbulent, the separation is delayed. Because the separation is delayed, the form drag reduces. Now what is the problem with the friction drag? The skin friction drag is lesser in case of laminar flow, and skin friction drag is higher in the case of turbulent flow. But what is happening is the reduction in the skin friction, the increase in the skin friction drag is much less than the reduction in the pressure drag, and that is the reason here in the case of second case B1 and B2, B2 has much lesser drag than B1. So we can say the drag of the object B1 is more than that of the object B2. That is the answer. So you understood, and this is the main thing which is used in our golf balls, where they use dimples on that. Okay, because of the dimple, drag is reduced, and because the drag is reduced, the golf ball moves to a larger distance. Okay, because the drag is reduced because of the turbulent flow and the form drag being reduced. There might be a question like this: why does golf ball move to a larger distance? Because form drag reduces. Okay, although skin friction drag increases. Now let us see the last case, that is 4 and 5. We will see what is the right answer first. Now here, when it is a airfoil, the wake region is very less in both the cases. Okay, so even if the separation is delayed by a bit, it is just a bit of delay. So what is more prominent here is skin friction drag. So if it is a turbulent flow, skin friction drag is more prominent than the form drag. So what is happening is the turbulent flow, in case of turbulent flow, the skin friction drag is higher, and form drag variation is not important. So drag of the object C2 will be greater than that of C1. I hope you understood this, students. So this is the main thing. There are two things. Again I will repeat. One is form drag, another one is friction drag. Form drag reduces or form drag reduces when there is delay in the separation. Friction drag reduces when it is low in the laminar flow and high in the turbulent flow. Now we have to see which is important. As in the case of the sphere or the cylinder, form drag is more reduced than the friction drag. Okay, whereas in this case the reduction in the form drag is very less because of the turbulent flow, but the friction increases because there is more area here. Okay, there is more area over here, and that more area increases skin friction drag. That is why C2 is greater than C1. Correct? So this is the answer. So answer is A. I hope you have understood this, students. If you have any doubts, please comment on the video. Also, you can also personally contact me. The WhatsApp number is given in the Facebook page. Kindly like my Facebook page also. So it is given in the description. Kindly contact me directly if you have any other any problem. Okay, any doubts, you can directly message me through WhatsApp. Thank you very much, students, and all the best for your exams.